So what was your question?
What's next?
That wasn't your question.
Where are we going now?
That wasn't your question either. You already forgot your question?
Pretty much.
Oh, must have been an important question, so I just ignore it then, right?
Sure.
You wanted to know what I was doing.
Yeah, what are you doing?
I'm measuring the valve. 309 and 8/10. What size is 5/16? Chart tells you what 5/16 is. Let's see, that's about a 4. So I measure, I do everything I do around here to the 10th. That includes setting my valve clearances. I don't just stick a 5/16 ring in and call it done, or whatever Jim's latest special $300 crappy reamer is. I use hones so I can make it any size I want. And I want it to be the size that is correct in the application. Not what I had laying around. Now this valve is way out of whack. Where'd you get this one from? This is 309, 3 to 4. Varies all over the place depending on which low spot I'm in. So we're going to go with the biggest one, 309, 4. It's also a minus, so put a little dash over there for minus. So 5/16 is 312 and a half, which would be 5, 312.5. Kibble likes using oddball sizes. That way you can't use a stock guide. You got to put new guides in your heads. Brilliant. They sell more guides that way. They should make a couple tenths bigger than stock so you can fix the old guide, put a guide in, put a new valve in it, make it all new and call it done. But no, they don't do it that way. That'd be too smart. Okay, I need my cheat sheet. These are cheat sheets. Are we working on a pan shovel?
No.
Oh. What about an Evo?
Evo.
See the cheat sheet? Guess what I call the cheat sheet?
So you don't have to do math a whole bunch of times that you've already done before.
100 times already? Yeah, that's exactly right. Okay, this is an intake valve. We run 1.4 thou clearance. That's called 14/10. So you go 1.4 thou or 14/10, depending on what digit you want to work to. You want to work to 3 or 4 digits. I like working to, I call out 3 digits, but I work to 4. Okay, this is 309.8. 309.8 correlates to a negative 13. So that's a minus 13. This one here is the same. Minus 13. Okay, this is an exhaust. See, exhaust. We work to 1.9 thousandths, or 19/10. Yeah, that's a half a thou more clearance than the intake because it runs hotter. Get that?
Yeah.
Okay, this is 309.4. 309.4 is a 12, negative 12. So this is a negative 12. Problem is I got this as my B in my hash. I'm going to put the X up on there, so I know that's a crappy valve. Okay, and this is 309.4 was the same number, wasn't it? Yeah, 12 again. Minus 12. So, kibble makes the exhaust valves a little bit smaller diameter. So, when you hone the hole, see the difference? There's only 1/10 difference in the actual valve guide diameter. Now, in the real world, you can go up 5/10 and it wouldn't matter. You could probably drop a couple tenths without mattering. Maybe. It might stick too, you don't know. Depending on how hot it is and how you break it in. So anyway, that's how I do it. So that's a cheat sheet. Now the cheat sheet is for my dial bore gauge. Next is the dial bore gauge. That'd be this thing. These would be standards. We're working to a 5/16 diameter guide, so we use a 5/16 standard, 312 and a half. Remember I told you that number?
Mm-hmm.
Okay, now you got to set this thing to 0. Appears to be pretty close right now. Do you like that number? Looks pretty close to 0.
That's pretty close. Yeah, that'll work.
That'll work for you?
That'll definitely work.
Now this is not a 1,000th bore gauge, this is a 10th bore gauge. So 1,000th is actually 0 to 1. Each one of those little lines is 1/10. In between each 10th line is a 50 millionths of an inch. You could probably guess a little bit closer to that if you want. You can go a quarter of a line, that's 25 millionths of an inch. That's 6 digits out in case you didn't know what that meant. I don't work the millionths of an inch around here, I work the tenths. But I will split the tenth to a half if I want. Okay, now I can take this and take that cheat sheet number, which was minus 13, right there. And I want this to be on the minus side of 13 and then final hone. That's what that number is all about. So, take our head over here, and we see what sides we got to work with. See how we are minus 35 to 3.5 thousandths right now, give or take. So I got to hone it down to 13 or 12, depending on what valve it was. The intake. See, it's 3 there. We're 4 way up here, see, almost 4. So that's how much we got to work with. We got 2.5 to 3 thou honing to do. That's why I use a kibble white guide, because they actually are honed to fit, which means it should be a round hole when you're done, if you hone correctly. So all I need is 2 valves, because they're both the same. So I can remember which one's which. I need this. Now as long as I don't drop this or screw it up, it should repeat pretty closely for the job. So you put those right there so you remember which one's which, because I'll forget. These are in my way, so we have to move them. These are worn out. You want to take these home as a Tatro gifts, or you want me to throw them away?
I'm good right now.
You all right with trash?
I'm pretty good.
Okay. So you don't want no parting gifts, okay?
I mean, I might take the other half of that tool there because I think it'd make a nice ashtray, but I don't smoke, so I don't think I really.
You don't need that.
I don't need. I definitely don't need it, but it sure is
cool.
cool.
I get is tire smoke. Does that count?
What's that?
Tire smoke. Does that count? Well, I also get exhaust smoke when the motor goes out, but we don't count that one.
Perfect.
Okay, I need one of those tools over here. I'm not sure which one. I'm guessing 1, 2, 3. I'm gonna go with 3. Okay, that's probably the one that's 5/16. Now, if you can read really, really small print, it should say 5/16 on that, but if it's not, it's going to be really loose in here. This has to be the right one. It's also worn out too. See, these don't last very long because so many guys I hone out. So if you take your manual and you cheat and grind it underside, it's good for another round of wearing away. Until you have to throw away and buy another one for $50 or whatever these things cost. That's just this piece here, not this piece. It's called perishable goods. It wears away. Or consumables in the hard material line of deal. Okay, so one of these, we're going to use these over these stones. So I guess it's going to be these ones here. Now we have a fine and a coarse. So you know we're doing coarse work when we use a coarse one. There we go. Where's the other head? Ah, lost it. We'll need that in a little bit. Okay, so I like to leave about 1/8 to a thou for final. So we'll shoot for that area. So we would want 12 and 13, so that means I need to hone this down to just under 2.5, just under 25, somewhere between 2 and 25 I'm going to hone to. Whatever I'm comfortable doing today. Some days I like more, sometimes I like less. If the hole's screwing me, I'll leave. I'll make changes. That sets the diameter and pressure kind of. It's cold here, so the oil pressure is a little low right now. It'll indicate it like that. Yeah, I hit it that way. Now, this is not the quick way to do a valve job, it's more accurate. It'd be nice if you have some cooling oil on the damn thing when you're doing this. Right. That one. Damn it. Close enough. You want to hold the head straight and not load it. Put a load on it, it makes the guide out around. Okay, I'm going to clean my hands off a little bit. Now you got to keep this wet with oil, otherwise it wears it away even quicker, because it's like lacquering compound. These holes small as grit. It wears away this, which gives you a false number. Okay, so see where we got right now? Come over here. See, we're 29:30 right now. See how even I got the hole? So we're about 27, 28 right now on that one.
Nice even.
Yeah, there's a couple tenths of movement there, but some of that's from grit. Remember, these holes are full of grit.
Right.
This one's right about 26 all the way across. See, that's how it should be. Doesn't really move. 26, I like that. So the exhaust, we need to take out another 2 or 3 more tenths. Probably 3 tenths out. The other one we got to take about half a thou out still.
And that's still on the course.
Yep, on the course right now. It'd be nice if the oil's actually going on the stone. The stone looks a lot better when it's got lubricant on there. It helps clear the grit away. I like the fixed stone like this, not the flip-flop one like they use for valve guides. The valve guide hone that you're supposed to have, use, all it wants to do is go around in orbit, which means this is going like this, while this is staying here, which makes the hole go like this, which makes the hole barrel shaped, more tapered. I don't like using that setup. Even though that's what you're supposed to use. Because this is harder to do because you actually have to hold the head square and straight.
You mean this requires talent?
Skill.
It makes it accurate.
It requires skill. So we tend to have some of that around here every now and then by accident, of course, but oh well. Okay, so this needs to be about 20, what do we got, 12 on this one? So this needs to be on 2 to 22. Okay, that didn't take off hardly anything, a couple tenths at most. So we need to take off some more. And the intake. It's a lot smoother than it was now. It's staying at 24.5, 25 all the way down. Alright, so that means that was 23, so I gotta take more off of that. Now the guide is long and straight and true now. Now it takes more honing to get it to come out. We took off all the high spots, rough machining, now we're going to go quick. Now I actually have to start honing. I got a little more pressure on it. Do a little more honing back and forth. That makes more strokes. Use a reamer to do this. The reamer gives you a bunch of chatter marks the whole length of the hole. Assuming it cuts straight to begin with. You get a very, very poor finish. But it is quick. Do it in seconds. Do it in minutes like me. No matter what you want to do. That's why they have different tools out there. They also have diamond tools that are supposed to give you speed in accuracy. I have my doubts about those, but I don't see the quality of how to read them. This one here with 22 now. 23. That's 1/10 out. That's because I got a crap machine. I'm doing everything by hand. It's hard to hold the 10th. This was 23, 24. Same 1/10 accuracy. For some reason, they always can't seem to hold a thousands accuracy, which is 10 times worse. I don't know what to say. I know why my stuff's not accurate. I don't have a clue why they can't do it right. I don't know if anybody else does it like this either. That means I must be doing it all wrong. Or all right, because I look at it. I didn't follow the Harley Davidson official method of doing that stuff. I start now, right?
Right.
Okay, that should be enough for coarseness. The hole's pretty straight, so I can go all the way down to 2 with no problem on this. I don't need a full thou to clean up. I try to keep the honing on a lot of my indicators, so I keep cleaning my hands off. Even though this is allowed to be wet. Okay, so we're at 2 to 21 now. This one's 21, 22 it looks like. That's the intake. And the intake is the bigger one, see? So we're 1/10 difference in the hole, we got 1/10 different valve sizes. So that head's roughed in. Now if I put that over there, you shouldn't get any damage to your fancy powder coat that you care so much about. I don't give a squat about. going screwing me. I wouldn't hold it straight. Alright, next one. See how rough that sounds?
Yeah.
It is rough. That's a ream hole. Real crap. It's also pressed into the head, which makes it different too, so it's not all that. Move my bucket over. See my drip bucket down there? Drips into theirs.
Huh.
You thought they just laying there for no reason, didn't you? There's usually a reason why I have things laying in certain places around here. This one's about 27, 28 right now, it looks like. Let's see here. That was the exhaust. This one's 26, 27. So this is bigger. This is quite a bit bigger than it needs to be. All right, so I can do more honing on the exhaust side. I'll keep filming or come back later, it's up to you. Initial rough fine cut before I go to start bringing it in. Warm up, so I get all off my stone now. 14, 15, we need to be at 13. We got 10th and a half to go on this one. We're 13 on this one. We're at 13 right there. Goes up to 14. I don't like being higher than my number. I don't care about being lower. Same thing, 1/10 of taper to it. So I got 1/10 to go. It's 13 to 14. I want to be 12 to 13, not 13 to 14. Loose is always better on valve guides. You don't want to stick a valve. Takes out the whole motor when you do. Stick 2 strokes each way. Sneak up on the number we want. Didn't do anything. Pour the towel out. So we want this pressure up even more again. The finer the stone is, the more you get off the pressure. More surface area, so there's more pressure than the same amount of cut. Coming out really fast. There's 12 and 13 now. See? 12. That's 13 right there. Now it's 11 3/4, 12 and a half, 12 and a quarter there. Okay, that was 13. The other one would be at 12. We are at 1450. Okay, so now I got kind of a feel about how much you take out. This way you screw up and take out too much because you get a lot more than one couple strokes. It starts cutting more than expected to.
That's usually less than good.
That can't get anything here. To 13 right now. Good, or it's going to be a 10 too much. Which one do you think it is? Too much. I don't mind being a little extra on exhaust, especially if you're going to run it hard. I'm okay with that. That's actually probably preferred. A little extra doesn't hurt on a hot rod motor.
There we go.
Okay. So remember the exhaust valve, one's a little bit more uneven than the other one. So that one's a little bit looser, so we can know which way that valve is going to tie or loose. mix and match the two. Pick up that extra half a thou, half a tenth. I didn't measure this yet. Ahead of myself. I honed it, but I didn't measure this yet. That's the way it is. Oh yeah. Got a lot to hold on these. Let's see. Here. On these small stones, it's very important to go the same number of strokes. Both ways you got the head on here. Makes a difference. Other stuff it's not done as critical, but on these little small ones it seems to be more critical. $13.14 on that one. $14.15 on that one. A tenth and a half on both. Which one? Think we're done? Alright, that one's good. 12 to 13. This one's probably another 10 to go yet. Nope, we're good. Just a chip one around. It was like a quarter of a tenth bigger than I wanted it to be on the high side. So now it'll probably be like the other one, a little bit loose. Nope, slightly bigger. Okay, good. Alright, we'll get it in there. Where am I in here? Lost my... You have to hold it centered up pretty good. Yeah, there's 12 right at the very top. 11.5 right there, so about the same as the other one. They're both pretty equal. I think 11.5 is our high on this one too. Let's see where we at here. 11.25, yeah, so that's the rear one. The rear one is just a tick bigger, a tenth of a tenth, a couple tenths of a tenth.
Couple tenths of a tenth.
Yeah, it's close.
I think that'll do.
You can live with those errors?
Yeah.
Oh, I'm glad. The whole reading was only a tenth, so, you know. That's less than splitting hairs.
Less than splitting hairs. I've got no hair to split over that.
Yeah, we're splitting hairs of splits.
All right. Splits
Okay.
of splits.
So that took, what, half hour to do?
Sure.
Versus I can run a reamer in 4 holes. No. Of course, it's a different quality of job when you're done, so. Oh well.
Quality counts.
Yeah, it takes time. Okay, time to clean. My favorite thing. Pretty accurate this time. Just a bad valve here.
Oh yeah.
It continues being bad.
Yeah, big time.
See, this one only missed by that little bit right there. This one's a little bit more off. Just that one that falls down, but that whole thing's bad. If you think that's really bad, we only took off about 1.5 hours. It's not like it's a big error. It just looks big. Another one. You're always twisting the hole to make sure it's flat. Everything you gotta do is try to make things more accurate. You know? Still not quite all the way across. You hear how it sounds when it's flatter. It's a weird finish. Dimple to it. It looks like it's got a dimple in the middle, but it doesn't. It's a hard spot. These are still like tipped or something pretty hard. Alright, that was the easy part. Okay, now for the fun part. Let's see how good this is going to work today over here. First thing I do is make sure you're on your 45 degree. Does it look like it was on 45 degree? See a dirty
Sure
line?
does. That dirty hash mark?
Yeah, that dirty hash mark was right on the money. Yeah.
Right on the money.
Yeah, I always want to make sure it's right on the money when I do this. I don't stagger my angles, I make them all the same. Now, the problem is you got 3 balls here and 3 balls there, and if you're in the low spot, it's going to kick your valve a little bit. You know, see those dark and things there, that will affect it out here when it moves around. If there's any dirt or anything in there, it affects how it runs out too. The collet ones that come in like that have rubber between them, they tend to be way the hell off for some reason. You'd think they'd be more accurate, but they're not. They're way off. So I have yet to come up with a valve grinder that's worth a crap yet for grinding consistently. including mine. If you can't get repeatability, it's no stinking good. I don't care who it is. So I'm always fighting that. See, that's a high spot right there. I just marked it, see? And then stick it in there, rotate it, give it a few marks back and forth. Here, dragging. Dragging all through here. We're in the same spot. We're dragging all across that same area. So this valve is high on there. 2 times I did it, it's the same thing. It's high in this area. Now it'll change from being here to here, the highest point, but it's always this area. So after we honed the stem and got it straight and true, look how bad that one is. Now when we're grinding this, we're at a very accurate number. Whereas before, they did it before that was all done, so it could have been cocked off a little bit when they ground it.
Gotcha.
So, but am I off, they off, everybody off? I'm in one league that everybody's off. We go for the best average we can get. But ideally, we want to be on the money each time, but in the real world, I don't think we have that. Here where it's grinding. I doubt if you can see it though, but yeah, there's a difference. See how smooth it is right there? And it gets rough over here. So we're getting that same out of whack number. So usually what I do is recenter it again just slightly, see if it changes. Here I came right back to the same spot. You can hear the chatter marks and now it's start grinding again. The stone's loaded up right now, you can hear it also. This stone's so worn out, I think it should be like way out here, so it's on its last legs. I need to break down and buy another one or go find another new one off the shelf. Remind me to do that. For sure. See the difference?
Yeah.
That's it. So you don't have too much you can do that because see it's a very small margin on these valves.
Yeah.
They're high performance. Okay, now we got to go over here, clean this thing off so I can see better. Oh, look at that, I can actually see the numbers now. I'm not just blind, I just couldn't see. Okay, so there's my secret number there that you can't see.
We'll remain that as a secret.
No, I don't care, you can film it all you want. This is our that angle. This is what makes it run better. See how it's cutting right up here? See that much now, it's cut at a different angle. Now you narrow that up to how big your seat's going to be. In this case, we're going to be a little bigger now. A little less, I should say. Okay, see now it came up a little bit further. See how they got thicker?
Mm-hmm.
So that's a good place to stop. So that little there will make a big difference. That's almost like doing a port job, just doing it a little bit. Because the closer you are to that valve seat, the more important it is. Can't get much closer than that. That's just off the valve seat. So that one's done. Now we do this one. This is one of the way. This is our valve here.
This is the worst of them all.
Yep. Watch you clean up the best.
You never know, right? You never know.
You never know. Clear ahead?
Oh yeah.
Is it me or them? Hell if I know. Sounds about the same. Move it again. that's all the way in now. And we're not talking the major numbers we're hearing there. You can hear half a thou out. Oh, these are exhaust valves. Uh-oh. I grounded at the wrong angle. Oh well, I'll make them both the same. I had the wrong back angle.
Dun dun dun.
I got the intake back angle on the exhaust. Damn. Well. Let me bring it in either. There it is.
No sense crying over spilt milk.
Well, I run about an 8-degree difference between the two. So we're off by 8 degrees. Oh well. Yeah. Good. Perfect. I'm picky. That's why I did it wrong. Don't forget to put it back on 45 though. Yeah, different tulip angles, different combustion chambers, all of that makes a difference on your angles. Okay. That'd be too much. It's a lot bigger than the exhaust. Sure to be repeating the same amount of offness there. Yeah, that time it didn't. Not repeating very well. Definitely to sharpen again. That's how it sounded like it was way out, but when I sharpened it was right on the money.
Mm-hmm. Yeah.
It's because when the stone gets kind of loaded up a little bit, and it basically cuts out where you're grinding. And it starts getting highs and lows in because it wore away. And that gives you that hopping noise, even though the valve is not out of whack real bad. It sounds like it is. So when I just kissed it, it's smooth as glass. It's all about knowing what your machine is.
Knowing what the machine's saying to you.
Yep. Sometimes it's always mad at you. Ooh, man, that moved in quick. cutting them off that one. About 2/3 on the back cut instead of 50/50. Okay. I'm not getting a noise I want to hear. That's the hardest when you move this. That's because I got the jibs clamped down pretty tight so you got less chatter in the machine.
Mm.
That's why I get a nice smooth finish on the valve. Plus it's cold and grease doesn't want to let you move with the oil that's on there. That's a secondary reason. You know so much I moved it for finish, I moved it like that far.
Mm-hmm.
Not cutting much off. Hard to see the different angle. The stone is sharp on both cuts, so it leaves a really fine finish on both faces. Usually the end one's a little bit rougher because the stone's worn. In this case it's so equal it's hard to see it. Okay. You have to see it in the light. See the difference? This line's right there if you see it.
I can see with my eye. It's hard to see with the camera.
Camera might see it later, but that's when the air goes across, it's a nice radius. It makes it like a radius even though it's not because you take out the sharp edges.
Right.
The next back cut, you blend this top angle into this. Would be your next cut you would do if you want to do a third cut.
Mm-hmm.
And that might hit, might not hit, depends if it's highs or lows. So that's your, if you're doing a racing job, you go in there and you really want to get nitpicky, you go in there and do that.
Mm-hmm.
You can also go in there and polish this thing with a grinder and give it a nice swirl to it all the way around. And blend this thing in a little bit.
Mm-hmm.
And that's if you're trying to get the last little nitpick thing you can get. You don't worry about that much. Just put more nitro in it. I'll be back.
Alrighty.
You forgot your question already again.
Well,
you keep like to ask questions off video, then you forget what the question even was.
You know, I was kind of curious about the different flow speed of air between the intake and exhaust.
That wasn't the question. But
okay, it was in relation to valve grind angles.
Might have been part of it. The question was, I screwed up by putting the intake back cut on the exhaust, is what the question was. So what's it going to matter? In the real world, it won't matter a bit to you.
Fair enough.
basically air does not want to turn. It wants to go straight. So if I go off the cliff, what's the air going to do? Is it going to go right that way?
Nope.
Or is it going to go down, hit about halfway down over there?
Right.
Of course, that varies by airspeed. The faster the airspeed, the less it wants to turn. The slower it is, the more it will turn. So airflow inside of a motor is usually somewhere between 300 and 400 feet per second, otherwise known as hauling ass. If you got a really high flow, high velocity port, you can be in 400 to 500 feet per second. Some vary, I think it's up to 700 feet per second or something like that, 600, some number, I don't know. Pretty high. So anyway, you can hit supersonic airspeeds inside of ports that are really restricted with big motors. So you have to look in relationship to that. Now your valve head is basically in the middle of your airflow. You're trying to flow into a hole. So my theory is if air doesn't want to turn very much, when you do porting, you want to have no sharp edges that's more than 7 to 9 degrees. It's either 7 or 9 is the maximum you go. Then it basically turbulates off the end of it, vortexes it, starts making swirls like this instead of going straight. And it's either 7 or 9 degrees. I don't know which one it is, but one of those two. So what I do on my valve here is we are at a 45-degree angle. The air is coming in this way. We want to follow the valve face and not turbulate, which would cause turbulation in the port here, which means it won't flow for shit. It basically shuts the airflow off.
So it goes slower.
Right. So I want to make a back cut that is no more than 7 or 9 degrees. So our angle's 45, so take 9 off that. What do you got? So I took 7 off. I do it at 37 degrees what I use. So that's 8 degrees difference, something like that. That's what I use. And then you got the angle to your valve head as your next angle. Now the exhaust, it's a different thing. Exhaust is going this direction, and exhaust, you want to actually kill exhaust flow a little bit when the valve first opens. Remember, it's in a really heavy pressure when you first open it, so you actually want to retard evacuation a little bit because it can over evacuate. It dumps the cylinder pressure too quickly, you lose power. So you want to slow it down a little bit. That's why you use a sharp edge on your valve here, whereas in this one here you have a radius on, or a chamfer on the top for better flow. You know, these aren't, they just have a little radius on these, but for racing, put a little chamfer on there too. So you do different things for different directions of flow. So this one here, I make it a little bit sharper, so I'll cut it down here. Yeah, I do like 30, 32 degrees what I do. So the standard out there is a 45, 60, and 30 is your normal angles forever that you've used. For racing, they get a weird angles like 55 degrees, 58 degree seat angles, which flow a lot more air at high lift. They suck at low lift. They're very hard to seal. They suck up a lot of length, so you run out of valve clearances. There's all kinds of things that are problems doing those. 45 is a nice good number. 30 degrees, which you use on a flathead motor or diesel motors a lot of times, which is very good for flow at low lift, because as soon as you open that thing, it's flowing like crazy, sideways. And so on a 4-valve motor, it'd be good too, because you want the air to go sideways a little bit, then go up. So, but the problem is sealing. You have to have a lot of pressure to seal at 30 degree. You don't have that angle helping you. It's like this instead of, this is easy to do, this is hard to do. So on our flatheads, we use 30 degrees, and we can screw around with that a little bit. Anyway, all of that's relative to what's going on. Does it make any damn difference in the real world? On a street bike? No, you're never going to notice it. On a race motor? Maybe. I don't know. I don't have a flow bench. I got a time slip. That's all I do. I do a bunch of little things. I go fast. Whether they work or not, I don't know. Who cares? I just do it. It makes me feel better. If I take my thumb and run them across the surface and it feels nice, I think it's good. If my finger fuck my port and run my finger through it and it feels good, I think it's good.
Awesome.
The bikes run better and go faster, so right or wrong, it runs better. So that's all I care about.
And it's got to be right.
It's right enough for me. I don't care. I got the record. You go get mine, fine. Go get it.
Nice. Thanks
So
for clarifying
there you go.
that.
So there's just more theory. In the real world, who cares? The most important thing is like everything, valve seal is most important. If you ain't got no seal, you ain't got nothing.
Gotcha.
Everything after valve seal is just the icing on the cake, basically. So you start doing all these back cuts and narrow up the angles. You narrow up the width of the seat here a little bit. That gives you more power, but it cuts reliability slightly. All of that stuff is like that. So there's a trade-off between street and racing. It just makes getting a good match between it. If the guy's doing more racing on the street, then you do more of this racing stuff for him. You're doing a high performance motor, so we make our margin a little bit thinner. We put the valve face right on the edge of the valve and sit her in a little bit. There's all kinds of little things to do. So it's all part of doing the high performance work. You got to tune it for the application.
Cool.
So there you go. Figure it out. Now, can I get back to work now?
Yeah.
Okay, so we're going to do some valve work now. So, do you know which valve goes which yet?
Yeah, the little itty bitty one.
This is the front one because I already marked it F. Because while you weren't looking, I measured the valve guide and I figured out which one was a quarter of a thou difference, and I put the crappy valve with that one. You didn't catch that.
I did not catch that.
You took a lunch break, I think you said. So this is what the front one. So that means this must be the rear one, right? So you put a big R on that sucker. Now the intake doesn't matter yet because we haven't decided. So which one do you want to be which? So we'll just make this one front. Make this one rear. How's that?
There we go.
You good with that?
That'll work.
These could reverse.
That'll
Doesn't
work.
matter. They're equal. These ones here are basically equal, but they're slightly different. So we're going to make front and rear. So that's a front, that's a rear, that's a front, that's a rear. So now you ladies up over here. Now somebody called me on the phone and got it all full of oil. Was that you? What? Are you flashing?
Yeah.
Oh, good. Does that mean your battery's dead?
Oh.
Oh, good.
You got a spare? Does it chirp? Does it tell you
Is it chirping
something?
yet?
Not yet.
Oh, I wouldn't worry about it.
E95.
No, the battery's good. I wouldn't worry about that. I don't know what all that shit means. I'm not a cameraman.
That's two of us.
Put your blinders on. We'll figure it out later.
There we go.
Okay, so I guess we're not going to work on these M8 heads now?
Not today.
Okay, so I got to figure out what the hell the bolts are. I'm still working on these, trying to make tooling for these things. So these are the bolts that don't work yet. So these I still got to make a valve guide driver and knock these guides out of here. I still don't know why they got the valves, the guides above the height of the head here yet. That never makes sense to me. Why would you put a stop on it and never use it?
We need to figure that one out.
Yeah, it's M8. They don't know anything either. So there you go. You see that latest thing, the lifetime now on these motors? Lifetime warranty?
No.
Yeah, just that's something that's got an email today. All right, take a break. Let's go to the phone.